Hey guys, this looks like a fun one. It says find the area of the blue rectangle. And the rectangle is twice as wide as it is tall. And it hits the semicircle in these various places. If you guys want to try this on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, let's connect this point to this point, and I want to focus on this triangle right here. First off, it's a right triangle because this is a rectangle. And second, it's isosceles because these two sides are congruent. That means it's a 45, 45, 90 triangle. And then since this angle is 45, we now know this angle. This plus this is a linear pair, which means they have to add to 180 degrees. So this angle will be 135 degrees. Next, let's finish up the circle, and I want to focus on this 135 degrees. This is called an inscribed angle, and if we look at it, it's cutting the circle into two parts, this red arc and this blue arc. A cool property about inscribed angles is they are exactly half of the arc that they subtend. So this red arc is going to be double the 135 degrees, so it'll be 270 degrees. And then since the red arc is 270 degrees, that leaves us 90 degrees for the blue arc. For the next step, let's draw this radius here and this radius here. And let's focus on this 90-degree arc. This angle right here is called a central angle, and central angles are equal to the subtended arcs. So this is going to be a 90-degree angle. And we usually notate that as a box in the corner. And since both of these are radii, they both have a length of 5. So if we connect this here, we have another isosceles right triangle. If we use the shortcut for 45, 45, 90 triangles, we can see this green side is equal to 5 root 2. And here's the steps of the Pythagorean theorem to verify it. And we just did all of this work just so we could get this green length right here. We can go back to here and let's bring back our rectangle. Looking at our rectangle, if we call the shorter side x, this longer side is going to be 2x. And we have formed another right triangle. Let's focus on that. And now we can do Pythagorean theorem to solve for x. We have x squared plus 2x squared equals 5 root 2 squared. We can bring down the x squared, and then this squared will go to both the 2 and the x. And this 2 will go to both the 5 and the square roots. So we have x squared plus 4x squared equals 25 times 2. X squared plus 4x squared is equal to 5x squared, and 25 times 2 is equal to 50. After we divide both sides by 5, we get x squared is equal to 10. And after we square root both sides, we get x is equal to the square root of 10. And now we know the shorter side of the rectangle. This x can change into root 10, and this 2x can change into 2 root 10. And now we can find the area of the rectangle. It's equal to base times height, where the base is equal to 2 root 10, and the height is equal to root 10. And that's equal to 2 times 10, which is equal to 20. Let's give it a label of square units and put a box around it. The area of the blue rectangle is 20 square units. How exciting.